In this video, we're going to be presenting a potential argument for why the big labs in the US, specifically the closed source labs such as OpenAI and Anthropic, might face a surprisingly large set of challenges from the open weight class of models, such as GLM, Chemi, Quinn, etc. And of course, in this video, we're just going to assume that the demand is there for these models. That they're, of course, there's lots of debate about their use cases, are they useful or not. But in general, we're just going to assume that there is this baseline demand for adoption. And the key challenge that these models could face, these closed source models, is an open source model that is basically good enough. And by good enough, I mean that the use cases that generate the huge amounts of revenue, even if they're operating at a loss, they still generate a very large amount of revenue, do not have infinite capability scaling requirements. For example, models that are predominantly used for coding or other generic white-collar tasks, summarizing emails, drafting some document for someone that nobody will ever read, this sort of thing, right? That people use LLMs for all the time, or reading the document that you didn't want to read, that sort of thing. A lot of these models do not need state-of-the-art performance, and that is already influencing model routing decisions. But if it becomes the case that there's basically a model that is sufficient for almost all of these tasks, which maybe there are, depending on who you ask, then that basically blows a giant hole in the revenue of both Anthropic and OpenAI. So, for example, right, to concretize this, if you're, a small business or something, and you want to vibe code a website or something to that effect, which is supposedly something that people do. So you'll use an LLM to code it up, right? If you're just making some generic website that has, whatever products you sell on it, that doesn't require Fable 5, doesn't even require Opus 5. And Fable 5, for example, currently is priced at tokens per million input output at $10, $50 on OpenRouter. I made a Scratch website in this sort of vein using one of the old Mistral models that is priced 2 orders of magnitude cheaper at 15 cents for input output per million. And, that's really all you need for this task. And so the requirement thresholds for email related tasks, right? Read this generic document that doesn't say anything, summarize it for me, and then respond to it. That does not require extreme 1 million thinking tokens either. So this is basically what I mean by a model that's good enough, right? That basically the vast majority of model usage is for these sort of simple tasks. Now, maybe there's an argument there that it's only for these simple tasks right now, because obviously most people are not paying on the sort of API token plans, at least that I'm aware of. And so if they're giving you free money by subsidizing it, then might as well use it on these random little tasks. But if people actually had to pay token prices, maybe they wouldn't, which is a potential argument, but we'll get to that later in terms of a response. But what are the real implications about this, right? Why is this a big problem then? As I said, it might blow a hole in their revenues, which then represents a substantial, potentially $3 trillion problem. And that's because Anthropic and OpenAI's multi-trillion-dollar valuations depend on every month having higher revenue than all previous months combined, in essence, which is, of course, how exponential scaling works. And if you suddenly have, a big revenue drop, that would probably be disastrous for their valuations. If revenue doesn't grow exponentially, that's already bad. If revenue decreases, that's a complete disaster. And so that also impacts obviously all of the companies that rely on their future money, right? A lot of build out or cloud commitments that rely on OpenAI and Anthropic's future revenue to pay for those future commitments. But if an open weight model reaches performance that's sufficient for the majority of coding use cases, for example, which, let's be honest, is mostly just unimportant SaaS slop before it was already AI slop, then that that can just be done with a cheaper model. And in a world of zero switching costs, where whatever coding tool people use, Cursor, OpenRouter, OpenCode, or any of these sort of tools, all of them intentionally make switching very easy, right? You can just type /model instantly in the middle of a session, switch LLMs. And so there's zero sticking cost or zero vendor lock-in for any of these services that these companies provide. And now direct to consumer, OpenAI, like having apps that individuals use is a separate, that might have more sticking power. This is mainly in the sort of corporate world. And obviously this only applies to token costs. As I said, if Anthropic and OpenAI are selling $5,000 of tokens for $200 a month, then obviously the companies will take the free money. But if this takes place when the subsidies are not as strong, then this presents a substantial hurdle. One could argue, in fact, that this is already taking place. It's just in the early adopter phase, since many users are subsidized, right? For example, Coinbase recently put out an article and a graph saying that essentially 100% of their code was LLM generated. Fittingly, the graph itself is obviously Claude made the matplotlib, but if we take this as true, which who knows if it is or isn't, it could be true, could not be true. People could be writing code and running git push and Claude code, but we'll just assume it's true. Then this indicates that what I'm describing has already come to pass. New models that improve 2% on physics reasoning benchmark number 35 are completely irrelevant to Coinbase. That doesn't matter at all. Only faster and cheaper models will, right? Like they already have all of their coding needs, which is basically as a software as a service company, which is what Coinbase is, right? That's everything. I mean, that's the whole product. That's all that's relevant is reducing the cost or increasing the speed. Now, you could argue that new models will unlock capabilities that are required for larger or more complex projects. And Coinbase is simply waiting to undertake these projects because the model capabilities don't exist yet. And I would disagree with that, mainly because the employees still exist there. If there was some giant project that the business would greatly benefit from, that the models aren't capable of handling yet, of course the employees know how to build it. So since that's not happening and none of the code seems to be hand generated, then these projects must not exist. Now, a further skeptic could say, actually Coinbase has layoffs, they have terrible employee morale, nobody has any energy or interest in advancing new projects, their extensive LLM usage has basically rendered their brains mush, and they have no capacity for difficult thought or real work, and so anything beyond drawing into a prompt window eludes them, and so they're just not going to do anything that can't be done with an LLM. Now that's possible, but that's perhaps wildly pessimistic speculation that can neither be confirmed nor denied. So we'll just put that in the maybe category. Have beyond just the cost, of course, there's a huge number of benefits of using open weight models, even if the costs were purely equal, like exactly for performance, right? You have control of your data ownership, right? You're not sending it, if you run the model in-house, you control 100% of your data. You can modify and improve the model to your specific use case. You can control the deployment for speed, etc., etc. Many benefits that exist. And even if GPT-7 or Fable 7 or whatever keeps improving on whatever benchmarks exist, it doesn't really matter that much for this argument, right? All that matters is that open weight models reach a certain capability that they might be close to, or maybe not. We'll see. But even if these future GPT-7, Fable 7 reach some irreducible vowel loss, right, and they get 100% on whatever benchmarks, the simple fact of the matter is that the market has sort of converged on the economic value of solving air dodge problems versus the economic value of building, CRUD apps. And that the order of magnitude is, there's several $1 billion difference in revenue there. So that's what I, am trying to convey, is that all of this depends on the revenue, and all of the revenue comes from tasks that maybe can be done for 2 orders of magnitude cheaper. And of course, businesses would like to save money. And so when they can, they will. Now, this isn't a problem at all until it's a problem, at which point it becomes a big problem, right? Because it's not something that will, necessarily creep up and you'll see a larger percentage of shares of AI usage that is open weight versus closed weight. I think, just like when people sort of transitioned to the sort of modern slop coding era, there was a threshold, in essence, a capability threshold, where it's like, kind of useless. Now, okay, I can be lazy and just slop code everything, right? There was a phase transition here in terms of, how much can you offload? And so once open weight models hit that phase transition and the capabilities are not, radically subsidized, then it just becomes a switch that gets flipped. However, as quickly as, probably way quicker than previous switches in terms of AI usage. Now, this is not an isolated thing that I've speculated on. Some investors are starting to realize this, and the reactions tend to fall in a few categories, right? Some people will say it's not a problem for the reasons I outlined above, but I think in general, if we consider, current revenue is essential for growth, and growth is essential for the companies to exist, and the majority of revenue comes from tasks that have already or will soon meet capability thresholds, then I think it's a very, there's a compelling argument in there. And the reactions tend to fall in a couple of different categories, right? The first reaction is often something like, the US or Western businesses won't use these, Chinese models because China is, not aligned with the US or whatever. But this relies on multiple faulty premises. First of all, it relies on the fact that the open weight models come from China, which doesn't have to be the case. I mean, it has been this entire time, but maybe someone in the U.S. Is capable of creating an open weight model that's very performant. That remains to be seen, but it's certainly not impossible. And then also conflates the idea of a model trained by a Chinese company with sending your data to China. Just because a model is trained on GPUs in China doesn't mean you have to host it there, right? Torch.matmul runs the same in the US or in China. So there's basically an endless list of US inference companies that will take this model and run it on their hardware, and then you just send your data to whoever that is. And so how can OpenAI and Anthropic solve this problem? And perhaps there's a variety of ways, but it seems like the dominant way was, TBD on how it plays out, is basically to try and get some sort of restrictions on open weight usage, which of course would secure if you restrict, you can't buy this cheaper product, then of course you have to buy more expensive products, and people will pay for their revenue. Since originally crafting this argument, a second thing happened, which was Chemi K3, which I think was even perhaps more impactful than anything in the arguments that I presented above. I won't go into the details too much here, but Chemi K3 I think represents not the practical business threat that these sort of cheaper, capable Chinese models represent, but it represents a very existential threat to these companies, because they are predicated originally on the assumption, right? Like, why does Anthropic do what they do? Because they believe that by making the LLM as quickly as they can, as best as they can, that they can basically stay ahead of the competition, right? If these models continue to improve at this pace, or whatever pace, right? Then if the derivative of this improvement is exponential, then you'll always stay ahead of your competition, right? So if you can keep improving time and time again, then, and use your improvements to stack upon each other, then you secure a moat, basically, and your moat is your sort of first mover's advantage times exponential. And so that was a key argument for the entire existence of Anthropic. And so that relied on the fact that basically, Anthropic models would always be better than Chinese models, because they started first and started improving first, and there's this looping effect. But with Chemi K3 released, there were benchmarks that it outperformed Fable 5 on, and so this is not just a cheap model. I mean, it is cheaper. It was half the cost of Fable 5, but it's not like some capable cheap model. It's in some cases better than their top tier, so performant that it briefly got banned in the United States model. And so what this means is that it seems like their thesis is not true, potentially, which has substantial implications for their business, right? Like, even if you lost all of your revenue to cheap, capable models, then you're like, oh, but the frontier matters for science and physics and very advanced cybersecurity. So we have to exist. We have to continue to exist. And I'm sure there's some government money that could get involved. And it's like, but if that's not true, if the capabilities in cybersecurity or physics or whatever can be had without these closed source labs, then they don't even have that pillar to rely on. And so this completely shatters this illusion that China is behind, or we're always 6 months behind, or they have to distill frontier models, right? Like, oh, you just have to wait for the next frontier OpenAI model to come out, and then they'll distill it, and then that's just what they have. But clearly this is not just distilled GPT 5.5. That much is obvious. And so that means they're potentially facing problems in the revenue direction, and potentially facing problems in the state-of-the-art direction. So a lot of speculative claims in here, but that's a set of arguments for basically why the big labs could have some big problems.